A child starts from rest at the top of a 4-meter long slide inclined at 20 degrees to the horizontal. If the child's speed at the bottom of the slide is 3.5 meters per second, what is the coefficient of kinetic friction between the child's pants and the slide? Now I'm assuming the slide is just nice and straight. That would make it too complicated if it wasn't. So here's the slide. I drew it much steeper than it really is. Inclined at 20 degrees. The slide itself is 4 meters long. Child just sits down, starts at rest, so the kid's not getting a running start or anything. Just sits down on the slide. Let's go. So he or she starts sliding down the slide. When the child is at the bottom coming off, he or she is traveling at 3.5 meters per second. I would like to know what the coefficient of kinetic friction between the child's pants and the slide, what that coefficient of friction is. Well, the coefficient of friction comes into play when we talk about the force of friction. So we will need to use forces again. So let's go ahead and draw the free body diagram. The forces that will be acting on this child as he or she slides down the slide. So there's obviously going to be friction, because we're asking for the coefficient of friction. What direction will friction be in? Up the slide? Yeah. What else is there? There's gravity and a normal force. Normal force, remember, is from any surface, and it's always perpendicular to the surface. Force of gravity, always straight down towards the center of the earth. Now this kid is not going to get going fast enough for drag to play a role. Drag, air resistance, same thing. So we don't need to worry about the drag force. You have to get going pretty darn fast for drag to really play an effect. Okay, so we have 3 forces. The sum of the forces have to equal ma. We need to look at forces in the x direction and forces in the y direction. Now, as a side note, what direction do you expect the child's acceleration to be in? Sorry, I hear a lot of mumbling, but down the slide. The kid starts at rest, speeds up, going faster and faster and faster, going down the slide. Now I'm intentionally drawing my acceleration away from my object. It's not a force. Acceleration is not a force. It's a result of the forces, but in and of itself is not a force. So the sum of these forces is producing this acceleration. Now we can choose to use our traditional coordinate system where x is horizontal and y is vertical, or we could choose to tilt our axis and make x along the incline and y perpendicular to the incline. Both work, but one's easier than the other. If we tilt our axis and make it parallel to the incline, number one, that makes friction and normal force both lie along the axes. And it also makes the acceleration only in the x direction. The y component of acceleration would be 0. So that makes it easier. If you choose your coordinate system to make it so the acceleration is all in one direction, one of the forces will add up to be 0. That's kind of nice. I like zeros. So let's do our coordinate system here. X along the incline, y perpendicular to the incline. So adding up the forces in the x direction. We have friction pointing up the incline. With the way we've drawn the coordinate system, we're calling down the incline positive. So we're going to have negative force of friction. Since it's up the incline, it's in the negative x direction. So minus force of friction. Gravity has a component. Remember, the x component needs to be parallel to the x-axis, the y component parallel to the y-axis. The x and y components must meet at a right angle. So the hypotenuse is the force of gravity. But we need this side right here. So where in this triangle is the 20 degrees? At the top. If you think about rotating the coordinate system, we had to rotate the y-axis by 20 degrees to make it perpendicular to the incline. So this side over here will be the force of gravity times the sine of 20 degrees. It's pointing down the incline, so it's positive. So plus the force of gravity times the sine of 20 degrees. The normal force does not have an x component in the coordinate system we've chosen. So those are all the forces in the x direction. That must equal the mass of our kid times the acceleration in the x direction, which is the kid's acceleration. So that has to equal ma. Now let's make a couple substitutions. We know force of friction depends upon the coefficient of friction and the normal force. So I'm going to make that substitution in. We know the force of gravity depends upon mass and the acceleration of gravity. So that's our equation as of right now. Now we're not going to worry about what we do and do not know yet. We're trying to get mu. That's the end result that we want. But let's not worry about this quite yet. Let's look at the forces in the y direction. In the y direction, remember, is perpendicular to the incline. So we have the normal force pushing up away from the incline. So that's in the positive y direction. Gravity has a component pushing down into the incline. So that's going to be negative. And it's going to be the force of gravity times the cosine of 20. Friction does not have a y component, so it doesn't show up in our y equation. These are the net forces in the y direction. So this must equal the mass of our child times the acceleration in the y direction. But with this coordinate system we've chosen, what is the acceleration in the y direction? 0. Fabulous. So let's make a substitution here. We know the force of gravity is mg. So this tells us that the normal force must equal mg cosine 20 degrees. So in this particular problem, the normal force is equal to mg cosine 20. No, we don't have all the information, but that's okay. Next step. The force of friction depends upon the magnitude of the normal force. So let's take this and plug it in for normal force over there. So in place of normal force, we're putting mg cosine 20. We still have mg sine 20. That all has to equal ma. Notice anything? There's an m in every term, so m's will cancel. It doesn't matter what the mass of the kid was. So it's good. Even if you think you need some pieces of information that aren't given in the problem, just keep plugging through. Just keep writing out your equations, making all the substitutions you can. The things that you think you should know will disappear. So our coefficient of friction, we know g. We still have an unknown here, the acceleration. So if we bring this term over to make it positive, and the a over to the other side, and then divide by the g cosine 20, As soon as we figure out A, the value of the acceleration, we will be able to figure out mu, the value of the coefficient of friction. We know G. We know our angle. Suggestions on finding the value of the acceleration. Kinematic equations. Fabulous. Without drag, there's going to be a constant acceleration along the incline. We know the initial speed is 0. We know the final is 3.5 meters per second. We know how far the child will move, 4 meters. So our kinematic equation, without time, so initial position 0, initial speed 0, our acceleration will be v squared over 2x. So 3.5 meters per second, square that, over 2 times 4 meters. Someone plug that in, please. We have agreement?
Oh, that's all right.
Maybe not.
1.53.
Anyone else do it?
Yeah.
Okay. So we know the value of the acceleration. So G is 9.8 meters per second squared. We need to times that by the sine of 20. Subtract the 1.53 meters per second squared. Divide all of that by 9.8 meters per second squared times the cosine of 20. I get 0.1978, so approximately 0.20 for the coefficient of friction. Units cancel. We have meters per second squared on the top, we have meters per second squared on the bottom. The coefficient of friction is unitless. It's just a number. It doesn't have any units associated with it. Now, please keep in mind wherever you have little g, we always put in positive 9.8 meters per second squared, because we're already putting the negative sign in the equation to say that it's negative. You don't want the negative sign and a negative value, because that would imply that now the force of gravity is pointed upwards. So wherever you have little g, always just put in positive 9.8. Put the direction of the forces in when you write your equations out. Okay? So our equations will give us magnitudes. Questions on coming up with any of those?